what's up, everybody? Welcome to Earth Science. Let's do just a quick run through everything we've done so far in tectonics, just to I don't know, put us all on the same page, I guess, or just to bring it back in our minds like the full story, since we're doing it bit by bit by bit. The Earth would have formed about 4.5 billion years ago out of a solar nebula, and that stuff was going back to the first unit. That's a long time ago. But this cloud of gas and dust eventually coalesced into our star, the sun, and 8 planets and a number of other dwarf planets and objects. Our Earth being one of them, and with all of the constant collisions and bombardment that would have been happening early in the history of our Earth, it got to be a very hot place inside of there. Plus some radioactive elements and radioactive decay helping that out. When it got hot enough, we could go through this process of differentiation, where the more dense stuff sank down to form the cores, the less dense stuff rose up towards the top, and we ended up getting this kind of dynamic Earth with these different layers. And what that's done in the time period that we happen to live, 4.5 billion years after the planet formed, the planet kind of looks like this, but it's a dynamic situation. Go back to older time periods, and the planet's going to look different, slowly, bit by bit by bit. So, these tectonic plates or lithospheric plates are riding around on the softer upper portion of the mantle called the Asthenosphere. So the lithosphere tends to move as one chunk. The Asthenosphere underneath, this convection, this is oversimplified and it kind of drives me nuts. But here in New York, that convection is what drives plate motion. Take college geology and find out that that's a more complicated situation. So these tectonic plates are all shifting around and moving, and those relative motions are where the action is, generally in terms of earthquakes and for some of them volcanoes. Divergent plate boundaries can happen on land, like in East Africa, where there's rifting, or a lot of them in the ocean where there's mid-ocean ridges and seafloor spreading, which should have been the most recent lesson. Convergent boundary, where they come together, and we looked at three kinds: ocean, continental, oceanic, or same thing up here, or continental. That's where subduction might happen, and really, I know that this was a ton of stuff, but it's part of it, you know. It's one of the heavier things in our science, I know. Keep it up. You're doing great. So getting all those down and understanding that where there's convection, the subduction can lead to volcanoes, or if it's continental, just in mountain ranges. So, this has been going on for, I guess early, I looked up Mustafar system. I've always thought that the Mustafar system, if you're a Star Wars person out there, and happy May the 4th, was kind of based on diagrams of what it would have been like on the early Earth. Thin crust, very hot. They didn't really have constant meteor bombardments in the movies, I don't think. There weren't any Jedi cutting each other to pieces in real life. But, maybe this planet's environment was kind of based on that idea of the early Earth. Thin crust, tectonically very active. But give it 4.5 billion years, and you end up with some larger chunks of continents, some big mountain ranges, and thankfully a thicker crust, so that it's not quite as nasty. All right. What else? A couple of diagrams. You have to be able to tell me about the density, pressure, temperature, and depth or thickness of all of these layers using this diagram. If you're still struggling there, let's meet up and talk a little bit. Outer core is a liquid. That little bit, it almost feels like trivia, but that little bit pops up here and there. Continental crust versus oceanic crust. Remember, it's in your reference tables, though we do have to have this thicker and thinner thing in our head. And that should probably just about do it. With one thing being, how do we even know any of this? Because we can't dig down deep enough, and we know by watching earthquake wave refraction. We see how these seismic waves travel throughout all of the layers of the planet, and it's unraveled that mystery, like an X-ray unravels the mystery of me having bones in my leg. I've never seen one. Why should I believe that there's one there? Well, an X-ray has refracted waves through my leg, and we've seen an image then of the bones that are in there. All of this again, when you did this, you won't be asked like specific questions on names like Wegener or anybody else like that, but it's kind of a cool story that led to how we figured out seafloor spreading. Seafloor spreading and the symmetry absolutely can be on there. Check this diagram out. I kind of wish I mentioned it more when I did this video, because this has pretty much everything. This is like what's going on in the Pacific. You've got an oceanic continental convergent boundary with subduction melting in a volcanic mountain chain. You've got the trench. You've got the mid-ocean ridge. You've got the random weird volcano in the middle of a plate that shouldn't be there. That's your hot spot, like Hawaii. And then you've got over here an oceanic with the volcanic island arc. So they really crammed a lot into this little diagram. I like it. That's pretty good. So earthquake waves is coming up. That said, please make sure that if you do not have it by now, you get a hold of me and we figured out how to get you one. You're going to need this reference table. If you're a fully remote student that got sent home, and some folks have confirmed that those arrived. If you're here, I've been handing them out. This thing is going to be used next for our next earthquake wave project idea we got to do. Okay. So what for today? What I'm going to have you do, this set of questions right here, I'm hoping feels pretty natural at this point. All right, there's 10 of them. They're not numbered. This is, and I'll give you the link in the survival guide. This is, I'm just going to do the answers in Google form, but it'll just say question 1, question 2, and so on. So 1, 2, 3, 4. If this isn't obvious, I'm sure it is. 6, 7, 8, 9, 10. Write those in there if that helps. If not, don't worry about it. If you can just go in order. Okay. So you'll do those 10 questions, do them on here or whatever works for you, and then I'll have a Google form that you'll plug in the answers. And then I'm going to have some of you work on this. This will be kind of where we buffer a little bit. Some people will do this. So if it is 5-5 and you're all caught up and everything else, which somebody was telling me, May the 4th for today, and then tomorrow's the 5th or something. I don't know. Is there something funny there that I'm missing? Let me know. Some of these felt a little funny. Like, I think I used to say this, Earth zits, places like Hawaii, where there's an upwelling of magma, that's going to be your hot spots. The Aleutian Islands one I thought was maybe a little bit tricky. Specific name of the convergent boundary off the island chain, Southwest Alaska. Let me try to figure out what I was saying here. This one was confusing. All right, yeah, I worded that one kind of funny. It's the Aleutian Trench, which the reason I said that was because it is what's specifically written in the reference table. So, hey, I don't know how to spell that, Mr. F. There's the answer right there on this tectonics map in your reference tables. Are there any other hard ones? I think that we should be able to get most of these on, look at that, ESRT page number. That's an easy one. You can do that. So bounce around here, try to find the easier ones, and I think you'll be okay. But again, this is really going to be 5-5 only. So if you are, because that's our Wednesday work day, we'll start new stuff Thursday. But if you're still catching up to this, then we're not going to sweat this crossword. All right, sound like a plan, folks? I wish you luck. You're doing great. I do really appreciate it. I realize these videos can be on the boring side, and class is very quiet. There's maybe different ways that we could do some of this, but there's ways in which it's really worked out too for some folks. It's been beneficial to work at your own pace. So I do appreciate that you're all working on this. Keep it up. Summer will be here before you know it. Take care, folks.